Hello everyone, welcome back to my channel. So in today's video, I'm going to talk about pseudocomponent, blend, and assay. It is basically a different class of material that are available in Aspen Plus that you can use to represent a hydrocarbon mixture, a petroleum product, or maybe crude oil itself. For example, maybe you have a crude oil from different gas field, or you have you want to specify kerosene, you want to specify jet fuel type A1, for example. You want to specify naphtha, you want to specify diesel, wax, basically any fraction of hydrocarbon mixture or petroleum product, if you will. Um, for this topic, I decided to divide them into three portions or three parts. The first part is basically we're gonna take it slowly, where the first part of the videos is where we're just gonna define our component, and then I will show you how to define and then modify and then maybe add new properties in your component. The second part of the videos is we're going to use a simple block to simulate a fractional distillation of crude oil. And then on the third part and final part of the videos is where I'm going to use a more, I would say, complex column to simulate fractional distillation of our crude oil. And for these particular videos, I'm going to use an actual data of crude oil that are taken from the Udang Natuna gas field located in Indonesia. But actually, if you see a map, in the map, Udang Natuna gas field is more closer to the peninsula Malaysia rather than Indonesia. But whatever, so yeah, let's check out our tutorial video. But before that, just a bit of introduction. As we all know, crude oil from various locations, there are fractions such as naphtha, kerosene, jet fuel, what else? Gasoline, diesel, fuel oil, lubrication oil, and then another class of material, another example of material would be output of Fischer-Tropsch reactor, low pressure or maybe high pressure, and then output of the pyrolysis oil reaction, or basically pyrolysis oil. They are all I must say weird. They are a cocktail of various chemical where nobody exactly knows the chemical makeup and how much actually the composition of each of the chemicals in these hydrocarbon mixtures. Therefore, it's very difficult to define them in Aspen Plus because we don't know. But the only thing that we know is maybe they consist of alkene, maybe alkyne, for example, and then cycloalkane, the one that contain benzene. They also have a sulfur and stuff like that. Therefore, it's very difficult to define them. Traditionally, to define them in using our normal method in Aspen Plus. So what's the solution to this? We can use a pseudo component, assay and blend type of component in Aspen Plus. Basically, it is this type of component class represent petroleum fraction, and they are characterized by their boiling point, molecular weight, specific gravities, and other properties as well, such as maybe for examples, if you are interested in specifying sulfur content in your gasoline, for example, if you want to include the cetane number of your gasoline, for example, or maybe you want to specify pour point, or you want to specify their viscosity, all everything can be input in the Aspen Plus. Now, in chemical industry, in my earlier videos, I always talk about no standard conventional component, which is quite simple and straightforward to be specified. But for crude oil, this is quite common in oil and gas industry to represent crude oil or any petroleum fraction as a pseudo component. Okay, there are three class of component Aspen Plus that you can use. The first one is assay. Basically, it is representing petroleum product where we don't know what is exactly the chemical makeup and how much it is in the oil, in our crude oil or in our hydrocarbon mixture. In this case, we need to specify distillation curve according to standard, maybe ASTM 86 and other types of standard, depending on what kind of data that you have. You also need to specify API gravity, molecular weight, average, as well as their property curve. For example, 4 point, amount of sulfur, maybe aspartame, certain number, amount of sulfur and stuff like that. The second part of the component is basically a pseudo component that represent a fraction of petroleum mixture within the specified range of TBP. TBP is basically a true boiling point. You can set a cut point to specify a range. Okay, why this is important is because when you have a crude oil, you have a full range. And then when you do a fractional distillation, it has a gasoline, naphtha, kerosene, diesel oil, fuel oil, lubrication oil, wax, and maybe atmospheric tower residue. And this thing can be defined as a pseudo component. It's basically a fraction. The last one is basically a blend. It's basically a combination of assay, two or more assay at a specified, I'll say, fraction. Maybe in a situation where your refinery received an oil from North Sea, for example, and then another one, another oil coming from maybe Gulf of Mexico, right? And then you decided to blend them according to a specified composition, mass composition, mole composition, whatever you want, and then they will generate a new pseudo component based on those mixture. I think that's pretty much it. Let's check out our tutorial problem. So in this tutorial problem, we're going to take it slow where for this first portion of the videos, I'm going to show you how to define, insert, and analyze our crude oil assay. And then we're going to use Udang Natuna gas field located in Indonesia. From there, we're going to generate various pseudo components based on the assay. After that, we're going to create a blend by combining the oil from Udang Natuna gas field with the crude oil from Alba, UK, North Sea, 70-30 proportion. And then we're going to use SRK property method. To those who would like to know where Udang Natuna gas field is located, if you see on the images on your left, the star color maroon, no, not maroon, I don't know what color is this. The star symbol here represents the location of Udang Natuna gas field. And as you see, it is more closer to the Peninsula Malaysia rather than from Sumatra, for example. It's quite closer to Peninsula Malaysia. But whatever, I think I have covered all. So yeah, let's go to our Aspen Plus software. All right, everyone, as you can see, this is my Aspen Plus software interface. I am right now in the component specification, I'll say, folder. And as I have mentioned earlier, we're gonna use Udang Natuna gas field. So what I'm gonna do is I'm gonna specify those crude oil from Udang Natuna gas field. So what I'm gonna do is I'm gonna go to the petroleum tab here. I'm gonna click Assay data, and then this window will pop up. I'm just gonna go. These are all of the list of example for crude oil from different region. Available in Aspen Plus, but if you have your own data, you can create your own crude oil, I'll say, component. But I don't have the data, so I'm just going to use whatever information that are available in the software. So I'm going to use Udang Natuna gas field. So I'm going to scroll down. Where is it? Let's see. Okay, there it is. So click open. Now one assay is done. If you remember, I also later I will need to do blend of this of Udang Natuna gas field. Sorry, with the UK Alba North Sea component. So I'm gonna add another one. So I'm gonna insert two together right away. Go to assay data. So I think, let's see, what is it called? Alba UK, right? Yeah, Alba UK. So should be, there it is. So Alba UK North Sea. These are all components. So open. I'm just gonna edit ID, maybe data set number 2. Okay, hit OK. Now I have 2 assay already in here. So go back to my selection. Click next. We're gonna use SRK. Just hit next. It's quite straightforward actually, but I'm going to show you what information that you will get. Give it a second. Okay, once I have the result, I will go to the assay or blend. Now, I'm going to analyze udang natuna gas field data. So this is the basic data. So the basic data is basically you need to provide distillation curve if you decide to insert your own crude oil data information. But in this case, you need to specify API gravity or specific gravity if you know the information. In here is basically your distillation curve according to a true boiling point, where this one on the first column, you have a percent distilled at temperature of 90 Fahrenheit until 1010 Fahrenheit. You also have different types. You can use STM D86, D1160 to boiling point with basis under vacuum STM 288, depending on what kind of data that you have. If you have information about light end, you can specify them here. You also need to provide your API gravity curve data. Basically, your API gravity for different, I'll say different percentage of crude oil being distilled. You also have to, option to use UOPK. Don't really remember, but I think basically you need to specify the K factor to specify to determine the density of your crude oil. But again, I'm not really an expert on the I'm not really an expert in petroleum, but you have option either specify specific gravity, API gravity, or UOPK. But this one is available in the database so that I don't have to specify my own. But before that, in the distillation curve, at minimum, you need to specify 4 data points. Then you can proceed. Right now, I have 1, 2, 3, 4, 5. So it's more than enough. But if you decide to include your own, you need to specify at least 4 database. This is light end, gravity, molecular weight, no need. Basically, to specify only 2. Distillation curve, as well as gravity, API gravity, specific gravity, or UOPK data. Molecular weight is, if you have, it's good to, you can specify, but if you don't have it, it's fine. Option here, nothing much. Under comment, if you see, this is the Udang Natuna Sea Indonesia. It's basically the crude oil from the storage vessel with SBM about 43 nautical miles from the north of Anbamas Island. But I'm not going to repeat it. It's basically a description of your crude oil. And then here you have a property curve. Property curve is basically an additional curve that represent that describe your crude oil. In this case, you have a sulfur percentage of sulfur at for the component that are being distilled at 8%, something like that. You also have a lot of things, basic nitrogen, hydrogen content, oxygen. All of this can be specified. You have, for example, you have an asphaltene content if you have the information. If you want to specify more of your crude oil, certain number, for example, content of bromine, content of iron, for example, what else? These are poor point of your crude oil if you have the information. But if you don't have any, it's fine. But in this case, they only provide sulfur content in percentage. Basically, 0.005% of sulfur is available in the distillate at 8% of the distillate, something like that. This is your result, but maybe later. Another thing that I would like to highlight here is your petrol characterization. So here you have your result. I'll give it a second. Okay, all of these are your pseudo component. These are all pseudo component generated using a default cut point of your what is it called? Of your udang natuna what is it called? North Sea data. Actually, it's both, if I'm mistaken, but let's see. Yep, these are the component breakdown for your, what is it called? For your udang natuna North Sea crude oil. You have a volume percent, weight percent, and then mole percent. These are just a distillation curve, API gravity, density, and stuff like that. All right, the next thing that I'm gonna explain to you is how to add a pseudo component. Let's say I'm gonna specify a gasoline, right? So gasoline. For gasoline, give it a second. All right, in here, I'm gonna switch conventional to pseudo component. Now I need to hit next. So in here, there are a lot of methods that you can use to, there are a lot of methods that can be used to, say, estimate the property of your pseudo component. So in this case, I need to specify average NBP is a normal boiling point. I'm going to use boiling point of, let's see, let's say, what's the boiling point of this? What's the boiling point of gasoline? Let's say 120. Okay, this is a random number. A specific gravity, let's see, is around 0.682. Molecular weight, I don't have. Vapor pressure, I don't have the information. Viscosity, let's say I have the viscosity. Okay, let's say temperature at say 30, right? Yeah, viscosity is around. Okay, I don't have the number in. Do I have a centistoke? Okay, let's say 0.44. Okay, let's have an example. I don't have the number, but this is how you define. And then water solubility, if you have the information, you can put them. Petrol properties, you can also include. Let's say I decided to include amount of sulfur, right? Sulfur of my gasoline, let's say it's around 0.0001. For example, I can also add more details. Maybe, for example, my cetane number. Maybe for gasoline, it is around 17. And other details if you have the information. So, and then you hit next. Just hit OK, and then let Aspen this estimate all of the necessary properties. And then if you go to your result here, if you go to result, you will have, let's say, it's going to take a while. If you scroll down, this is my gasoline boiling point. This is my API gravity, specific gravity, I think. What else? I think I could be wrong. API gravity, specific gravity. This one is probably UOPK, molecular weight, critical temperature, critical pressure of your gasoline. That's the second part. The third part is your blend. How do you want to insert blend? It's quite simple. Go to specification. Let's say you want to say blend, right? And then it is a blend. Choose blend, and I hit next. All right. I'm gonna do by mass. So I'm gonna blend udang natuna gas field with alba gas field. again, if I have the additional distillation curve for the blend, then it's good, but I don't have it. But if you have, you can just simply click and then you can provide the information. Let's say here is 70, here is 30. Hit next, and hit OK. All right, in here you have all of the, I say, let's see. Yeah, in here you have the result or the composition, if you will, of your what is it called? Of your blend. Give it a second. It's loading. It's quite slow. Yeah, it's taking time. I don't know why. Um, oh, sorry. It's not loading. I'm sorry. I don't know why. It's in here. It's in the component breakdown. I'm sorry. No wonder. Okay, these are the weight percent of everything. These are weight percent. Does it count? I don't know how much. 6. Yeah, I think it counts to 100 percent total. These are blend composition, distillation curve if you have any. I think this is the distillation curve of both, if I'm not mistaken. The calculated distillation curve. These are just a component breakdown. And then in here under petrol generation, you have their own, let's say PC40C, right? Let's go to the result of the petrol characterization. Okay, my Aspen is not responding. Okay, PC40, they have their own boiling point, API gravity, specific gravity, UOPK, blah, blah. And then they also have their own molecular makeup. I think I have covered all of them in here, but if you want to know details, yeah, you just need to go to the help menu and then read more. Or maybe in the future, I think I will do, based on this, I will do a simulation on fractional distillation. Again, I think I have covered all of it when it comes to specifying blend, assay, and pseudo component in Aspen Plus. And then what are the option that, what are the properties that you need to insert? What are the details that you need to insert in your Aspen Plus? So yeah, actually for this one, right? For the component breakdown, I have created a graph for you to see what's the percentage, what's the distribution uh, of the component based on the boiling point. So yeah, let's go back to our PowerPoint presentation. All right, everyone, as you can see, this is basically all of the data that I have extracted from the Aspen Plus, and then I just simply plot weight fraction as a function of normal boiling point. So as you can see, this is just it goes up and then suddenly jump, and then at different temperature they have their own fraction. But if I were to guess, this is just a random guess. No, it's a kind of like I'm not saying random. It is basically an approximation of the temperature of how much of the fraction coming from is belonging to the refinery gas. So basically, the first I would say section here is a refinery gas. The second section is basically a petrol or gasoline, naphtha somewhere here, kerosene, diesel, fuel oil, and the rest is basically have residue because they have normal boiling point of around 350 and above. In here, I can simply say that heavy residue is around accounts for 62% of the udang natural gas fuel composition, and then you have fuel oil total 10.2%, diesel 8.7%, and kerosene 9.9%, and so on. The second part here is basically a cumulative weight fraction, where basically I just add them up. So the total fraction will be 100. It is just a normal curve. But as you can see, majority of it are just a heavy residue. Again, as I said, this I would say range is just an approximation. Just I just randomly, I don't say random. It's kind of based on the a quick Google search, the petrol and gasoline is around 100 degrees Celsius boiling point. So I just decided to have this as my as the range for gasoline, naphtha, and kerosene, diesel, and fuel oil. So basically, those are the information that you can extract from Aspen Plus. Well, I think that's pretty much all for me. Again, what we have learned in this video is basically how to insert, how to define, and how to analyze your petroleum product. You can define them as assay. You can also define them as pseudocomponent. You also can define them as blend, depending on uh, what is your requirement. Of course, the in my tutorial video, I just simply show you based on the actual data that are available in Aspen. But if you have your own data, feel free to insert the information in Aspen Plus, and you pretty much get the same thing. And then if you also have additional information, such as maybe, for example, pour point as a function of temperature, density is a function of temperatures, a certain number, pour point, amount of asphaltene, amount of sulfur, amount of iron, nickels, all those information can be specified to further, I would say, to give more detail to your particular crude oil. All right, guys, I think that would be all for me. If you like the video, give it a thumbs up, consider subscribing to my channel, and I will see you guys again in my next video. All right, bye bye, and have a very nice day.